Okay, partial fractions, lesson 2. This is about repeated roots. What that means is if you have a fraction, a complicated algebraic fraction like this, and on the denominator you have a root that's repeated, that's squared, then you need to deal with it in a certain way. And the way you need to do that is to have, in this case, 3 fractions added together. One of them is with this on the denominator, another one with that on the denominator, but we also need one with the square root of this, with the single root that's repeated as the denominator. You will not get the correct answers if you forget that. Now I'm going to do this longhand and show you how things cancel out. Once you understand how those things cancel out, then you don't need to do it longhand. You can just take a little bit of a shortcut. Okay, so I'm going to multiply everything by x plus 1 squared along the top, and by this thing. Oops. There's my denominator. Right, let's deal with the b. The b I'll multiply by that one and by that one. And the c I'm going to multiply by these two. You'll notice that we have an x plus 1 on the bottom, and you also have x plus 1s at every bit of the top. So we can actually cancel one of those squareds and that one with this. So what you end up with is a times x plus 1, 2x plus 1, plus b times 2x plus 1, plus c times x plus 1 squared. All over x plus 1 squared times 2x plus 1. If you're happy not doing that line of working because you can see that this is just going to cancel, then leave it out, jump straight to this one. If you think you might lose some of the factors just by jumping straight to this, then incorporate this line of working. Okay, now I'm going to multiply everything out. So here I'm going to have 2ax squared, a 3x there, plus an x is a 4x times a, so 4ax, and an a, plus 2bx plus b, plus cx squared, plus 2cx plus c, all over x plus 1 squared times 2x plus 1. Now I'm going to equate the constants. So the x squared, 2a plus c, has to be 11. I'm going to carry my working on over here so you can see it all. So 2a plus c equals 11. Equate my x's, coefficient of x's, so 4a plus 2b plus 2c, 4a plus 2b plus 2c, and that's got to equal, these are coefficients of x's, so that's got to equal 14. And then my constant, a plus b plus c has to equal 5. A plus b plus c has to equal 5. Now we have 3 equations now and 3 unknowns. You can use your calculator to solve that. Your Casio calculator has a simultaneous equations with 3 variables option on it. You can use it there, or you could use the second method I used in the first part of this chapter, where you substitute some values in. So in this case, I'll substitute in x is minus 1, and then I'd substitute x is minus a half. Either way, you should get answers of b is minus 2, c is 3, and a is 4. don't forget then to write your original fraction out in this form with a, b and c written in it. So you've got 4 over x plus 1 plus minus 2 over x plus 1 squared plus minus, oops, what am I doing? Plus 3 over 2x plus 1. So this complicated algebraic fraction with a repeated root can be written as those three simpler fractions added together.